Everybody, Mr. Covey here, and this is talking about solving systems of equations. So there's kind of a couple ways to think about this. I hope that you guys kind of remember this. So when you're solving a system, what makes a system different from just a normal equation is when you're talking about a system, you have two equations. Okay, so we're not solving one equation. We actually have two equations, and then there's two variables. So basically, how do you solve a system? Is you take two equations with two variables, and you try and solve it for both variables. How do you do that? Well, there's three different ways to do it, but so one of the ways is we'll talk about first is graphically. Okay, so there's kind of three different ways. The first way is graphically, to graph them. And then there's two other techniques that are algebra techniques, and one of them is called elimination. And one of them is called substitution. Both of the algebraic techniques to solve these equations involve taking the two equations and the two variables and trying to mush them together to get one equation with one variable. If you can take two equations with two variables and get one equation with one variable, then you know how to solve it, because you guys know how to solve one equation, one variable stuff. And both these algebraic techniques kind of achieve this goal in different ways, but both of them achieve this goal. But there's also graphing, okay? So another way to think about this, solving a system with two equations with two variables, if you think about it really graphically, what we're really doing is figuring out where two lines intersect. Okay, that's what we're really doing, figuring out where two lines crisscross, intersect. Okay, it's the same idea, it's just another way to think about it. Okay, so graphically, this isn't that bad. How do you figure out where these two lines intersect? You graph them both, figure out where they cross. So let's graph this first one, 1/2 x plus 3. I'm going to start at the y-intercept of 3. Slope is going to be 1/2. Rise 1, run 2. Rise 1, run 2. Okay. There's my line. Graph the next one. Kind of continuing that pattern there, and I get this one. And then to solve the system, I'm trying to figure out where they intersect. Well, it's right there. They intersect at 2, 4. X is 2, y is 4. That's the point where they intersect. That's the solution to the system. Okay? And what happens is if you plug in 2 for x here, you get out 4 for y. And if you plug in 2 for x here, you also get out 4 for y. That's because it's a point that they both have in common. Okay? Go ahead and pause and try number 2. Solve this system graphically. This one's kind of a trick question. Look at those two lines and you try and say, where do they intersect? Well, they do intersect. In fact, you know they don't intersect because what do those two lines have in common? Well, they got the same slope. So they're going to go on forever and ever and ever right next to each other, and they're never going to crisscross. So considering we're trying to answer the question, where do these lines intersect? You're like, they don't intersect. So what's the solution? There is no solution. So don't forget that when you're solving a system, sometimes there is no x and y that work for both of them. There is no time that those lines intersect, okay? Overall, though, graphing a system is not a good way to solve it. Because if you think about it, we just kind of got lucky that we found that point of intersection. Imagine if the point of intersection, instead of being at 2, 4, was at 300, 862. It was way over here. We'd never be able to see that point. Okay, so rather than graphing them and trying to figure out where they intersect, we're going to rely on algebraic strategies. Okay, there's 2 of them. I hope you guys all, this will come back to you. Once we do a couple, the first one is elimination. It is, how do you do this? You know, the name tells you a lot. You try and eliminate one of the variables. So if you look at these two equations, and you'll see the x's are stacked up and the y's are stacked up. That's really nice. It really helps you do this elimination thing, because you kind of just want to get one of the variables to go away. So if you look at these two equations though, and you add them together, well, none of the variables are going to go away. I'm still going to have two variables. I'm going to have one equation now, but it's got two variables, and that doesn't really help. So you might be looking at it, and you're like, oh, but it almost looks like one of the variables went away. If only this plus 6y here was a minus 6y, then the y's would go away. We can easily change that by taking the second equation and multiplying it all by -1. So we're going to keep the top equation the same. We're going to take the second equation and multiply every term by -1. Again, the reason we're doing that is to try and get it to a point where when we do add them together, we get -6x plus 7x is 1x, and the y's get eliminated. They went away. Because now we have an equation that says 1x equals -2. That's an equation with just one variable. The only variable is x, and so we can easily solve that. In fact, it's already solved. X equals -2. You can divide both sides by 1 if you want. But we solved it. Now keep in mind, don't stop here. You're trying to figure out the point where they intersect. That's what we're trying to figure out, where these two lines intersect. Well, I have the x, but I still need the y. So I can go back to either of the first two equations and plug in the x and solve for the y. Okay, go ahead and solve this equation real quick. Okay, so you should get -1 for your y. Cool. Excuse me. I want you to pause and go ahead and give number 4 a try. Yeah, I think you guys can do this. All right. So I looked at this and I said, oh, I have -9x and 18x. I want this to be a -18. Oh, I can just multiply it by 2. Okay, so I chose to eliminate the x's. If you instead looked at this and said, I want this to be a -7y, so you can eliminate the y's, that's totally fine. That's totally a technique that works. You can eliminate either variable. I chose to eliminate the x's. I multiplied that first equation by 2 to get this. Then I added these two together, and I got the x's to eliminate, and I had an equation with just y's. I figured out y. I plugged the y back in to get the x was -1, and it'd be nice to write my answer as a point. -1, -4. That's the point where those two lines intersect. Okay, we'll do some practice with it, but I hope that's coming back to you as an algebraic technique to figure out where two lines intersect, called substitution. Called elimination. This next one is called substitution. And again, the name tells you a lot. You take one equation and you substitute it into the other one. So if you look at this, you look at that first one, you know what y equals. Y is the same as -5x minus 23. So if you take your second equation and instead of writing y, you write -5x minus 23, you end up with one equation. And what's nice about this one equation, it only has x's. It only has one variable. Go ahead, pause, take a minute to solve this equation. Okay. So you should have distributed the -2. Don't forget about distributing. At those parentheses, got to distribute. Gotten to this point, combined like terms, gotten here, subtracted the 46 over, divided both sides by 4, and got x equals -6. Don't forget, you got to go back up here and plug it in. And I'd plug it into this top one. That's the easier one to plug it in. So take it, plug -6 in the place of x so that we can figure out that y. Okay, we end up getting y equals 7. Again, you can use your calculator to help you with this. Don't forget, at the end of the day, it's nice to write it as a single point. So your answer is -6, 7. Okay? You can always plug that in. If you plug in -6 for x, you should get out 7 for y. If you plug in -6 for x and 7 for y here, it should equal 22. Okay? All right, let's do one more substitution together here. Things a little trickier about this one is one of the variables isn't by itself like it was here. So that made that substitution process really easy because you just grab that thing that equaled y and put it in the place of y. But here, you don't have like y equals something or x equals something. But you can very easily make one of the equations look like that. And the easiest way to do that is to grab this second equation and just move the x over. Because then the y is by itself. And you got x minus 3. So by taking this equation and writing it like this, now it's all ready to be substituted in. I'm going to take x minus 3 and I'm going to stick it in the place of y right there. Okay, let's do that together real quick. So I'm going to do 8x minus 3, not y. I'm going to stick x minus 3 in the place of y. And I'm going to solve this equation. 8x minus 3x, distribute that, plus 9 equals negative 11. Combine like terms. Subtract 9, trying to get the x by itself here. Divide both sides by 5, and I get x is negative 4. Don't forget to go back up and plug that x value into one of the equations to figure out y. Okay, and I'm going to plug it in right here. Negative 4 plus y equals negative 3. Well, negative 4 is positive 4, so 4 plus y equals negative 3. I'm going to subtract 4 from both sides. We get y equals negative 7. And then I'm going to write my answer as a point. We are going to practice this in class on Monday/Tuesday a bit, so don't worry. But I hope that you're like, oh yeah, I kind of remember doing this. Cool. Thanks for watching this video, guys. That concludes it.